Hello, everyone. Thank you. I'm Yshayy. I'm the CTO of Livecycle, and today I'm going to talk about a self-contained development environment. I'm going to start with sharing an experience I had like a few years ago. So back then, I worked on an internal company open source solution for feature flagging and configuration management. So it was an open source solution, it was public, and we want to encourage many developers at the company to contribute code to this project. In order to facilitate that, we've organized an internal company-wide hackathon. Because the project was called Tweek, we called it a Tweekathon. And it was we were excited, the team was super excited for seeing what the other developers are going to do with the project. We created like swag and t-shirts and added documentation and created an organized backlog of missions specifically for this event. And at the end, the event came and, well, it didn't work that well. The problem was that most developers in the company were struggling to make the project work locally on their machine and trying to build and debug and develop features for this project. This project was complex with several microservices in different programming languages and databases, and also there was like a rich UI. And the thing is, it was very complex, and it was a hackathon when the developers, again, spend most of the time trying to make the project work, and our team like moved from station to station and trying to fix all the bugs that the developers were encountering and encourage them, yeah, you can do it, and try like to add new features. So that was, at the end, it didn't work that well. And today I'm going to talk about the challenges of creating a good experience when onboarding a new code base, especially if it's a complex one, and what are the problems and how we can solve it with some different tools and techniques. Before we begin, a few words about myself. I'm a developer. I'm a full stack developer for a decade or something like that. I'm passionate about cloud development, backend architecture, Docker, functional programming, lots of stuff related to programming. I'm also the creator and maintainer of Tweek, an open source cloud-native feature management solution, the one I mentioned before, and I deeply care about simplicity, consistency, and elegance in code bases. A few words about Livecycle, the company I co-founded. We are building collaboration tools for development teams. We aim to bridge the gap between coders and non-coders, and it's something, this project is in a public beta, so you can check it out if that sounds interesting. Okay, so let's start to talk about the problem. How does it feel to start working on a new complex code base? So first of all, we are going to try and build and run the project, but we might have the wrong operation system like Linux or Windows or Mac. We might have missing or conflicting SDKs or programming language runtimes. And in many cases, we have like these package managers that throw random errors that we don't know what to do with them. I mean, they are not random, but they feel like random because they are very difficult to understand what's going on. And after we tried and failed, we'll read the README and try to make it work. Maybe we'll need to run some magic scripts. Maybe we'll need to install some tools and dependencies. In worst cases, we'll need to do something very like changing the host file or install root CA, something that is very intrusive. And assuming we make it all work and we can build and run the project, now we are trying to develop on it. And it doesn't always work that smoothly. In many cases, the debugging doesn't work, like if you want to put some breakpoints. The IDEs have problem with autocomplete or dependencies. code watch and build loop are not necessarily working, and we need a tool like Watchman. If we're working on a front-end application, auto model reloading might not work because some issues. We might have additional problem with external dependencies like SAS that we are using, and maybe course or other something random that we are going to encounter. And then we try to run integration tests, and that usually doesn't work out of the box, especially if it's like with Selenium or other browser testing frameworks, or maybe the setup is complex for the environment. And well, the worst thing about it that we might need to do it like over and over again if we left this project and start working on another project for a few months. Maybe once we came back to working on the same code base, we'll encounter the same problems again and again. And the thing is, I mean, why is it so difficult? Why do we encounter all this problem when working on complex code bases? And again, many of the reasons are because of different OSS operation systems, or fragmentation of SDK and runtimes, and maybe the thing is on work on my machine syndrome. So, I mean, if something is working on my computer, so in many cases I don't know again how to make it work again. So it just works, and I'm not going to try again to install this project or install these dependencies. In many cases, I will even not upgrade my machine because I don't want to do like all this setup, or maybe I'll like postpone it. There are a vast amount of different tool chains, IDE, extension. The development flows themselves became quite complex. Our machines are polluted and overloaded with tools. And the thing is that environments today and code bases today and tools are like changing rapidly in active repositories. And at the end, there are lots of other reasons, but at the end we waste a ton of time and have lots of frustration. So what's the dream of development environment? So in my opinion, I want development environments that are consistent. So everyone will get the same experience, which is like predictable experience. They are reproducible, so it's possible to destroy and rebuild them. So if I did some trashing in the development environment, I can destroy and rebuild it like immediately. They are isolated, so if I'm working on several projects, they are not affecting each other, and they are not affecting my host machine, so it won't be like polluted. And they are self-contained. So all the dependencies and tools and SDK and CLI or whatever that we need for development are defined and packaged inside this development environment. And I mean, it's very exciting to see today that it's actually possible to achieve these kind of development environments by running these environments in containers. So, and I think that many of the attributes I mentioned usually like resonate with the material we see around the containers and their benefits. So, a few years ago, 3 years ago, VSCode, one of the most popular IDE, added support for development inside a container, inside a remote container. And the idea is that the IDE is running locally on our machine, but on our host machine, and we have like a good and responsive experience. But the backend of the IDE, the terminal, the language server, the file system, like all the CLI and SDKs are running inside the container. So that way we can create an experience that is more consistent and still get like a very good experience in terms of like user experience. So the backend is running the container, the front end is running on our host machine. So I'm going to show an example how we can use these techniques and technologies. All the examples and slides are available on GitHub. All the tools that I'm using are open source or free to use projects, so they're not something like, I'm not going to show something that you can't like do it yourself. And these examples are not bulletproof, but like they work and they showcase the experience we can get when we are starting to use these development containers. So I'll start with the first example. And this is like a simple CLI tool for creating ASCII art from images. It's written in Go, in an old version of Go. So let's open VSCode. So this is like a regular VSCode, and you can see that I have like a Go here, and I have dep, which is like a dependency package manager, like an old one for Go. And the thing is, if I'll show you, second, yeah. If I'll show the terminal for my own computer, you can see that I don't have Go or don't have dep. The reason that I have it in the terminal here is because this terminal is not running on my host machine, it's running in a container. We can see it also in the indicator here in VSCode that we are running inside a development container. So what this development container contains? So this is the configuration. We can see that we have the extension of Golang. We have some settings, like VSCode settings. And the most important thing is the Docker file here that define the image that we are running inside, the image of the container. So we can see that we are using a base Ubuntu image. We are installing Go 1.16. We are setting some environment variable, like we don't want to have Go modules because this project is like using old version of Go. We're installing several other stuff related to Go, like tools. I'm installing the package manager dep here, so that's why I have it in my shell. And we can see that I also configure my shell to have like a Git and Golang extension. So you can see that I have like autocomplete for, like if I'll go, I'll see all the autocompletion here, and it will be the same with Git. And also the shortcut of Git, so like GC and stuff like that. Okay, so I have this development container, and I can run the application here. And this application takes an image and turn it into ASCII art. I'm going to put this image. And I'm going to get an exception because this library currently doesn't support like reading an image from an HTTP address. Only for the local file system. We can see the code here, what's happening and what code we need to change to support it. And it's basically the open image file here. And you can see that I have like full like autocomplete and everything like is working. I'm getting like a good Go experience because everything like is configured with the right extension and folder structure and stuff like that. So I'm going to go to a branch with this implementation. So we can see that I can also use like Git and like everything from the SCM. And here I have like a support for download the image, like very small code, just this kind of notifications. And I can just run it. And we have here the local of Python in like ASCII art. And again, it's very easy to work. Usually doing this kind of change takes less time than making the environment work, especially if it's like another version of Go. You can see that I'm running a specific folder because in the past you need to like clone Go repositories to a specific folder to make the IDE work well with them. Another thing that I'm going to show is that I can use the dependency manager here, and I can run the test. And the thing is that this dependency manager, again, it's old, nobody uses it. So the thing that I can run it inside the dev container means I'm not polluting my PC with something that my desktop with something that I don't need. So it's quite nice. So let's sum it up. We saw here, also every change that I'm doing, I can see like the source control changes here. So like the SEM thing, let's see, Git status. So we can see the changes here, and we can see them as well in the UI. Okay. So we saw the development container. We saw that we are working with a remote terminal, we're doing remote code editing, and there's an integration with the source control management. So we have like branches, and I did check out to a specific branch. So it's very useful, and also connect like with a GitHub provider, or you can pass like the credentials of your SCM provider. In addition, we saw that we are configuring our environment. So we set the runtime SDK and CLI of Go. We have environment variable. We configure in our shell, and we define the extension we want to use. And that means, again, that everyone that is going to open this project is going to get a great experience out of the box without doing like installation and configuration. So that was like a simple project. Let's go to something that's a bit more complex. So this is a simple Flask application that sends email. We have some challenges here, like we want to run and interact with a server that is running inside a container. So how do we expose it? We have a secret to manage here because of SendGrid, and I'm going to show also how we can debug this server. So this is my second example. Let's start by looking at our development container. So we see the Python extension here. We can look at the Docker file. This actually is very, very simple. We are installing another tool called SOPs that deal with secrets. It's a tool that was created by Mozilla, and I'm going to show how we are going to use it for credentials, for protecting our credential to SendGrid. And also in the Docker container, you can see that I'm doing like a port forwarding of 5,000. So first of all, I'm going to show like the secret example here. So we have like a credential to SendGrid. And I'm going to use a tool that's designed to encrypt this kind of credentials. So we see that we have in the repository a secrets encrypt JSON that have a send API key and mail default sender, but we don't see like what's the value there. To see how we're going to decrypt it, I'm going to show it with another example file that I have here that have the key some secret number, and I'm going to decrypt it. So I'm going to use SOPs -d and the name of the file. And you see that I got the secret number. I can also edit this file. And like change the value here. And I'm going to get a new file, a new encrypted file. And the good thing about this file that I can check it into the repository, and everyone can use it. They just decrypt it with their own PGP keys. PGP key. In this case, I'm using a GPG key. Sorry, but the thing is, it can be also connected to other encryption service provider. So currently, I'm just using my GPG key to decrypt it. So my init code for this repository is actually taking this secrets here that are the SendGrid API key and put it inside a .10 file. So that's happening like automatically when we create a container, and we install also the Python requirement, and I can run the application. And let's see, my application is running here. I have an email, I'm going to send it. And here I have an example in Melinator that I got this email. So the server is not working. I can also open, so the reason I'm seeing this here is because this port is forwarded. I can also see it here in the editor itself, the same thing. And another thing that is very useful is that I can, let's set it like that. I can also put breakpoints. So if I'll go here and I put breakpoint here and I'm going to send it. So again, we got a very good experience. We can see the data here. We can put like go step over step and have like a very good like debugging experience. And again, everyone will get the same experience because it's defined inside the development container. So they don't need to configure anything and it's just going to work. So that's the second example here. We saw that we are using secret encryption inside the repository. So the idea is that we are having these keys and we are going to, we are encrypting them like the SendGrid API key. The metadata is saved and encrypted. So it's very easy to do like this thing. The metadata is, for example, the name of the key. This practice is actually used in like GitOps context. So there are other solutions like Git Secret, Git Crypt, and other. In this case, we are using a Mozilla SOAPs, which is a very nice tool. We said that we can define in the IDE setting the, so I didn't show it, but the launch JSON configuration define how we are going to attach the debugger. The port forwarding is designed to do like the port forwarding on the localhost. That way I can connect to it. And that's like the first two examples. Are there any questions so far? Let's see. Okay, so I don't see any questions, so I'll move forward. And so the next project I'm going to show is the one that is deeply personal to me. It's the first. It's Tweek. It's the system I started my presentation with. So this is like a very complex project. We have several microservices, several databases, multiple programming languages, cross-service communication, very complex architecture. So let's go to the dev container of this project. And we can see it here. So first of all, we have the Docker file that like have install Docker in Docker. So we have like another Docker inside this dev container because I'm going to use the internal Docker to run like all the databases and stuff like that. I'm also running here like the Zash extensions for plugins for Docker, Git, Golang, and .NET. I'm installing .NET, I'm installing Golang in a specific version, Node.js and Yarn, and I'm installing Tilt, which is another tool that I'm going to show. Because again, this project is very complex, lots of microservices, different programming languages, and several like dependencies like database and stuff like that. So that's the Docker file that contains all these SDK and tools that I'm using. So you can see that I have like .NET, I have Go, I have Node, basically everything that I need for this project. Okay. In addition to installing like the SDK, I also installing like the extensions for the IDE. So I have the extension here of Docker. I have like Golang Go, C#, and Prettier for like prettying the code, that the code will be like pretty. Okay, so I'm going to run all this application, and I'm going to use here another tool called Tilt. So Tilt is basically a small like a tool that do like orchestration of a development flow on top of either Docker Compose or Kubernetes. So here it's connected to a Docker Compose file. The Docker Compose file, if we look at here, it's kind of like depend all the services and the dependency, the environment variables, like everything. And when I'm running this project, Tilt also had the capability of doing like hot code reloading and rebuilding containers on changes and stuff like that. So I'm going to run Tilt, and we can go and see in Tilt UI here. Let's see. Here we can see all the services that are running. For each service, I can see like the logs, and we can see that we have like the database here. We are using here Redis. We also have message broker, object storage, and lots of dependencies. And this is like the home page, and I'm going to show that I'm going to do like a quick change of code. So let's change the welcome to PWC 2022. Let's make it a bit more welcoming, like that. And we see that we add like hot model reloading of these changes. So this was like a specific microservices for the editor, but we see that we can have a very good flow. And basically all that what developers needed to do is like doing like cloning the repository and doing tilt up. Basically, that's it. So it's a very good experience for something that can be very complex. And also it goes for the other services in like in different programming languages. So everything just works. And I can't emphasize how amazing I think this technology is, because I mean, I wish that we had it like a few years ago when we work on Tweek, because it can save so much time in translation and also allow us like to create the experience we want that developers will have when they are working on a specific code base. So I truly believe that it's like an amazing technology. The last example I'm going to show, and it's like a very, I'll do it quickly. So we saw here, before we get to the example, let's talk a bit about what we saw here. So we are using nested containers. We use Docker in Docker. We are running Docker Compose. We have watching and rebuild on every code commit, hot code reloading if possible. And we are using here both Docker and Tilt. Also, we are mocking cloud dependencies. So we have databases that we are just downloading the images of the database, for example, Redis, Mongo, and Postgres. And it can also be like wild compatible solution, like Minio is an open source alternative to S3 that is wild compatible. We have our OpenID Connect Mac server that is used for authentication, that again is wild compatible with OpenID Connect solution like Google or something like that. And the last example I'm going to show, it's related to Kubernetes. Here we are going to install a very complex environment that is like based on more sophisticated kind of tooling. So Kubernetes is an orchestrator that can run lots of workloads and can be like very complex system. It can be like a CI system or a platform or many other stuff. Here we have a project that is designed to monitoring the cost of Kubernetes pods. And to run it, we need a Kubernetes server. We need metric server inside the Kubernetes, and we need Prometheus, which is a time series database, in addition to running like the Go code. So what can we do with Kubernetes? I mean, if you work with Kubernetes before, local development is already difficult. We have fragmentation, so many like versions of Kubernetes. And the thing is that if we use like a single Kubernetes distro and version, it can make our lives much easier. So I'm going to show an example of how we use a Kubernetes inside a dev container. So that's the last example. You can see that I'm using a tool called K3D to create a cluster. If we go to the Docker file inside this dev container, so I'm installing K3D, which is designed to run the Kubernetes inside our dev container. Elm, which is a tool for package managing Kubernetes dependencies, and the other stuff Go and Node because we have like UI and we have a backend. And I'm using the same technique as using a tilt. Here my tilt file is a bit different. So we have like a Kubernetes resource, not a Docker Compose. We can see that I have like a Kubernetes running here. Another thing that is interesting is that I'm using Kubernetes manifest to define the dependencies I want to have. So here I have like a manifest that defines an Helm chart, which is a package in the Kubernetes ecosystem of Prometheus, which is a time series database. And again, everything is done declaratively. So everyone that is going to use this product is going to have like all these complex dependencies installed. If I'll go to tilt up, I can see, let's see. We can see the application here. Oh, I didn't stop the project there. They're running on the same port, but it doesn't matter because it's just going to allocate it to a different port. So I'm going to show it here. So we see that we have the product, we have the API of the product, we have the UI. We can also go inside this UI. And it's running on port 1891. And here we can see like the dashboard for looking at the cube cost. The thing that is going, I mean, it's going to take some time to load, so I'm going to show some stuff in the meantime. This is our Kubernetes cluster. Oh, I'm not in the right dev container, sorry. Did I close it accidentally? Too many windows. Yeah, so here I can show in the meantime, we can do like K3D cluster ls and see the clusters. And I can tear down this installation and I can also like create it again. And everything is working relatively very fast. That's one of the benefits we are using K3D here because it's a very light distribution of Kubernetes. So let's summarize this last example. So we are using K3S and K3D. It's a minimal Kubernetes distribution that can run in like several seconds. Clusters can be created and recreated. We have Helm controller that allow us to install Helm charts declaratively. And we have again tilt facilitate building, pushing, and running image. What we see here is very like something inside something inside something. So we have a Docker host that run our dev containers, that we have the IDE, and also the Docker in Docker that run Kubernetes node, that run containerd, that run the application. So it's complex, but we get it like out of the box. And if we'll put this configuration visually, it will be something like this. So no more demos. So I've shown examples of container development environment. Things that are really cool is that the development environment configuration is also source control and correspond to the application code. So it can like work for a while and can be like maintained. The developer machine stay clean, as you saw. It can scale well to multiple environments without conflicts if I run several of these dev containers together. And it can run locally or remotely on my local Docker host or on a Docker machine in the cloud. Our setup in Livecycle, I actually used that in the last year or even a bit more. And we have like 10 of microservices, front-end without model reloading, our own Kubernetes custom resources, external dependencies, GraphQL engine, full-blown CI system, container, lots and lots of stuff, and very complex environment for our solution. And the thing is that even with all this complexity, the time it takes to tear down and download and rebuild all the cluster and the dependencies is less than 15 minutes. Like for setting up the developer machine in that case, time to build and run and test code changes is less than 10 seconds. Time to onboard a new developer is less than 3 hours, including like remote provisioning a dedicated host on AWS. Very fast time to introduce new tool, 5 minutes, because we can just update the Docker file and everyone get it. There's no work on my machine occurrences, no strain on our developer machines when we are working remotely. Developers need to deal less with secrets because they are encrypted in the repository. We are also using data seeding, so developers have initial data to work with. And our team work with both Apple Silicon and Intel Mac, so it can work very well. There are other optimizations that it's possible to do to make the dev environment even load faster, or that we can remove some stuff of the initialization. And there are some drawbacks. I think this technology is amazing, but it does take time to create the initial setup. We have additional code to manage. There's no standard for dev environment, so that's something that, I hope that in the future we'll see a standardization of this configuration. So currently, because there isn't such configuration, we are coupled to VSCode, Docker, Git, and Linux, and there are some performance issues. I think the biggest problem here is that we are coupled to VSCode, and in the future, I believe it will be much more easier to use this technique with other editors. So Gitpod use similar configuration to dev containers. JetBrains, Gateway, and Fleet provide this kind of capabilities, will provide this kind of capabilities in the future. Fleet is currently in beta, but from what I understand, it has like first-class support for remote development in containers. And I think that like everything we see is like a big part of a larger trend to put like more stuff in the repository. So we can see that nowadays we are putting our specification in the repository, linting, style guidelines, documentation, the CI pipeline definition, as we see with GitHub Actions or similar products, design system, infrastructure as code, secret, as I showed the example there in SOAPs. And I think that in the future, we'll also put here the configuration of our environment, of the development, how the development environment is going to configure, can be like configured, and how we can create an instant experience of when using development containers. I think that this kind of configuration, I like to think about is like, I have a repository that is like self-contained. All the code, tools, knowledge, definition, and processes related to the project are inside the repository. Git is a single source of truth. The code is more accessible. We lower the barrier of entry. The applications are portable. And I think we'll see a lot of emerging tools ecosystem that are built on this concept of like having a repository that I can just open and run it or understand it and how to use it. I've shown lots of tools here. Here I have like a slide with a cheat sheet of the different tools and what kind of problem they solve when we're thinking about creating this development environment. So you can use this configuration. And everything is also available on my repository here, and I will put it in my Twitter as well. Yeah, I think this is like from the template. So thank you very much.